So the other day, we spent some time looking at a number of rock samples, and we went through and we started to realize with those rock samples that we were getting differences in densities, that some of the streaks that we were getting were not easily discernible based on the chart that we were doing a comparison between. Part of the issue that we had with densities was when you use a larger graduated cylinder, accuracy is going to be important. So if it's harder for you to get the exact volume of a particular rock sample, your density might be slightly off. And that could lead to some of our issues that we had with identification of rocks. Some of the things that also may have been an issue was when you're using the streak plates, I noticed a lot of people were taking their sample and they were pressing really hard to get a streak. And we shouldn't have to push overly hard on a streak plate in order to observe a color left behind. And so I think that probably ended up with a situation where we had some discrepancies in our outcomes. I would like for you to still finish that and submit that document. There are a few people that still have not submitted it, but we're going to consider that practice for this class. I will put it in the grade book just as a practice assignment, and I will click on it will not be scored. So it's just kind of like, hey, there's our first attempt at identifying some rocks. And what I did this weekend was I put together a rock identification lab that's less open to interpretation. The variables in it are unchanging. And really what it is a matter of going through a document, looking at the characteristics that these rocks in the document are exhibiting, documenting those characteristics in a chart, and then going through a process where we can identify based on those characteristics that we can see. In this document, it will tell you if you are correct or not. So you can just simply jump back and say, well, I got that part wrong, so it jumps you right back to what are my other options, and I can follow along with my other options, and thereby develop some learning. So if you could, please go to your digital lab notebook, also to the Google Classroom, and then on today's agenda, I have on our desktop my digital lab notebook on the virtual desktop. I would like for you to open that up, and I would like for you to scroll down to slide number 35 and copy that. And I would like for you to paste it in your digital lab notebook. So slide number 35 is our interactive rock identification lab. It has 19 different samples. It includes texture, grain size, minerals, layers, scratches glass, fizzes with HCl, is it igneous, metamorphic, or sedimentary, and then the rock name. You are going to be completing this chart using the interactive simulation. This is what the simulation looks like. I put it on the Google Classroom, as well as it's linked right now on our agenda. So you're welcome to use it there as well. We're going to click on one of the rocks. I don't care which one you click on. Maybe you like one better than the other. You're going to click on one, and you will notice that there are 19 samples here. We're going to start with sample number 1. When I click on sample number 1, it shows me the rock. This rock may look familiar because we've already spent some time observing a rock that looked very similar. Once I've clicked on it and I can observe it, it then says click on the rock to begin. Sample number 1, it wants to know what the texture of the rock is. And maybe you're sitting there going, boy, I don't recall very much about texture. There is a link that is built into it for texture. Notice we have crystalline, clastic, glassy, and other, And if I know these 4 terms and I'm fairly confident in them, I could easily click on them, but maybe I need to review what texture means, so I click on the texture link. And it's going to take you to an explanation of texture. Texture is a rock's, of a rock can be crystalline, clastic, or glassy. Crystalline. This is when the mineral crystals with flat, shiny surfaces that reflect light like little mirrors. We see crystals. They can be coarse-grained or they can be fine-grained. And we have 2 examples over here of coarse-grained and fine-grained. We have coarse-grained crystalline structures, and we have fine-grained crystalline structures. The next one is clastic. This is a mineral or rock pieces that are stuck together to make up the rock. These pieces are named according to their size. There are 3 different clastic sizes. There are coarse grain, there are medium grain, and there are fine grain. Fine grain consists of things like clay or silt. Medium grain are those about the size of fine sand or medium-sized sand. And then coarse-grained are larger structures like pebbles or small sections of rock that you can actually see. Glassy is when the rock's surface is smooth like glass, and we've got a couple of examples showing glassy. And then there's also other, and these are oftentimes formed from dissolved minerals or organic material like rock, seashells, coral, plants. Oftentimes they're things like fossils, and they are usually very fine-grained. All right, so now I'm going to jump back up to sample 1. You'll notice in the upper right-hand corner, I can click back to sample number 1. So based on what I observed, is the texture of this rock crystalline, clastic, glassy, or other? It is crystalline. It does have a crystalline texture. Are the crystal grains large, coarse-grained, or small, fine-grained? And in this particular slide, it'll actually show you the difference. Is there one that matches above the other? Here's the example of fine grain, and here's the example of coarse grain. Most likely they are coarse grain. Okay, so I'm going to scroll back up to the top. I am going to click on large, representing the coarse grained crystals. They are large. And the rock is coarse grained with larger coarse grains. Does this rock contain light colored minerals, feldspar, quartz, or is it made mostly of dark colored minerals like biotite, hornblende, and olivine? Mostly light colored. Very good. So we're going to click on light colored. And the rock contains both light and dark colored minerals. Are the minerals lined up in stripes or bands or layers? No, they are definitely not. And it gives a couple examples there. So the rock does not have layers. Will this rock scratch glass? So if I click on the little test, and I can see a little streak on the glass. Yes, it will. Sample 1 will scratch glass. I can then click next. And I've got all of the information about this particular rock. It is crystalline. It's coarse-grained. It's light and dark colored minerals, or has light and dark colored minerals. There are no layers, and it scratches glass, meaning that it must be harder than glass. So then I can click on sample number 1 is, and it will tell me what that sample is. This sample is granite. Granite is an intrusive igneous rock that cooled slowly from hot molten rock or magma. It is buried deep under the ground because the rock cooled slowly. The mineral crystal grains are large. Granite contains both light and dark colored minerals scattered randomly, meaning that they're not arranged in rows or bands. Granite is commonly used as a building material for floors, walls, countertops, and a lot of other things. Granite is the most abundant rock on land or our continental crust. Varieties of granite include pink granite, gray granite, and red granite. So there we've got some additional information. So as I go through each one of these samples, I'm going to jump back to my digital lab notebook, and I'm going to fill in the entire section of the chart for that particular sample. You're going to keep all of this data, because then on our Google Classroom, if you scroll down under the rock, cycle and plate tectonics materials under the classwork tab, I believe it's probably one of the last things in the stream as well. There's a rock identification lab assignment. You are going to complete the rock identification lab assignment in a Google form. You will notice there are some questions that you are going to answer, and then you're going to identify each of the different samples. Sample 1, 2, 3, 4, all the way to sample number 19. And you're going to put that information in the Google form and click submit. If you would like to have just a separate document that shows all of this material, on that document that we were just looking at, our interactive rock document, if you go all the way back up to so on the Google Classroom, under the rock identification lab assignment that I just pointed out, we're going to go to the rocks identification lab. Oh no, that takes us to the link. That's not where I'm looking. It's on our agenda. That's where it is. On our agenda, there is a lab folder that you have access to. For all of it, it does?